All right, let's talk about the sum of angle measures of a polygon. All right, the sum of the angle measures of a polygon. So first off, polygons are flat, closed-sided figures with straight lines. So we're gonna make a table of common polygons to start with. And we are going to think about the name of the polygon and the number of sides that the polygon has. Okay, so we're going to create a table here. Common polygons, we're going to talk about its name and its number of sides. I'll draw 9 down. 1, 2, 3, 4. There we go. Okay, first off, the smallest polygon we can have is a triangle. And a triangle has 3 sides. A quadrilateral, and do make this chart and do make sure you're spelling them correctly, has 4 sides. A pentagon, because you will reference this table quite a bit, has 5 sides. A hexagon has 6 sides. A figure with 7 sides we call a heptagon. A figure with 8 sides is an octagon, like an octopus, right? 8 legs, that's why it's called an octopus. A nonagon doesn't mean no sides. A nonagon means 9 sides. A decagon has 10 sides. And a dodecagon has 12 sides. So those are the 9 figures that we are considering. All right. So when we are looking at a polygon, so like this would be an example of a triangle, right? A quadrilateral could look like that. A hexagon, I'm not going to draw all of them, but a hexagon would have 6 sides, so it could look like that. A pentagon has 5 sides, so it could look like that. All right, so these are all polygons. For each of these polygons, we call angles inside the polygons interior angles. Okay, so put that in your notes as well. We're building some knowledge here that we need to use going forward. Interior angles are angles inside polygons. Okay. And we're going to go ahead, we're going to mark them in our polygons with stars. So like this is an interior angle, this is an interior angle. All those corners inside the figure, those are called interior angles. Okay. So a hexagon is going to have 6 interior angles. A quadrilateral has 4 interior angles. Notice that its number of angles matches the number of sides. Triangle has 3 interior angles. Pentagon has 5 interior angles. So then we can reason that a dodecagon would have how many interior angles? It would have 12 interior angles. It would match the number of sides. Now we can figure out the sum of all of the angles of any polygon. There's a formula that we can use, okay? So to find we call it the polygon angle sum. So this is the formula that you're going to be using a lot today, okay? So if we consider, we're going to say for the polygon angle sum that n is going to equal the number of sides. So in our formula, n is going to equal the number of sides. The way to figure out the sum of the angles is you would do n minus 2 and then multiply that by 180 degrees. And then that will give you the sum of the interior angles. So pause the video if you need to and get this all written down because you need that information. It's going to be very important. Okay. All right, so let's talk about how we use this. Now we know that that's the formula. Let's talk about what it's going to look like to use this formula. Okay, so let's say we have a nonagon. And I want to know the sum of the measures of its interior angles. So I want to know what is the sum of the measure of its interior angles. So if I have a 9-sided figure, if I added up all the angles inside, what would it equal? Well, to figure that out, I'm going to go, okay, a nonagon has 9. So I told you this chart would be important. 9 minus 2, because I'm doing n minus 2. And then I'm going to multiply that times 180. Okay, so 9 minus 2 is 7. I don't know why I did that on the calculator. 7 times 180 is 1,260 degrees. So every single nonagon, every single 9-sided figure has 9 angles, and those 9 angles together equal 1,260 degrees. Okay. This works, so we know, something that you already know because you've known it for years, is that a triangle, the angles all equal 180 degrees. You've learned that in previous years. The angles equal 180 degrees. Well, now we can use this formula to prove that, okay? We can prove that the angles equal 180 degrees because we take the number of sides. A triangle has 3 sides. We subtract 2 from that, and then we multiply it by 180. So 3 minus 2 is 1, and 1 times 180 is 180. So that's how you use this formula to calculate the sum of the measures of the interior angles. So on this triangle, if I added up these 3 angles, like if maybe this is 60, this is 60, and this is 60, together they equal 180. That's what this information is telling us.